the steps for doing your first derivative test. First thing you're going to do is find your critical values. Critical values, we discussed before, is where the first derivative is either equal to 0 or does not exist. So take the first derivative of your function, set it equal to 0, figure out where that happens and where it doesn't exist. If that's the case, you're going to plot your critical values on a number line, select test values relatively close, nice numbers to work with, to the left and the right, or in between them if you have multiple critical values, and evaluate those test values in your first derivative, because what we want to observe is the sign. If the sign on the test values is positive, then you're increasing on that interval, and if it's negative, you will be decreasing on that interval. Now, if you change from one to the other, if you change from positive to negative, from increasing to decreasing, that means increasing, decreasing, you've got a local max going on. If you change from decreasing to increasing, so you were decreasing, then you were increasing, you have a local min going on. If you don't change, then it was a critical value that didn't produce a local max or a local min. So let's try this example. It says find where the graph of the function is increasing, decreasing, and it has local extrema. All right, first thing we're going to need is our first derivative. So dy dx will be equal to 12x cubed minus 48x plus 0. So let's set this equal to 0. All right, this exists everywhere, so that's not going to be a problem. We're not going to get critical values from it does not exist. Let's go ahead and factor. Since our degree is greater than 1, common factor will be 12x times x squared minus 4 is equal to 0, and 12x times x plus 2 times x minus 2 is equal to 0. So now we're in completely factored form. We're going to go ahead and take all the variable factors and set them equal to 0. So I've got one here, here, and here. So x is equal to 0, x plus 2 is equal to 0, x minus 2 is equal to 0, which gives me critical values of 0, negative 2, and positive 2. So number line, and we want to plot these values. We have a negative 2, we have a 0, and we have a positive 2. I would recommend, so that you can keep your eye on which ones are the critical values, to box them in. Now what this does is it separates us into intervals. We've got this first interval from negative infinity to negative 2. We have a second interval from negative 2 to 0. We have a third interval from 0 to positive 2, and a fourth interval from 2 to positive infinity. We need test values. We want nice numbers to work with. So we'll pick negative 3 as a test value, negative 1, positive 1, and positive 3. These are going to be the little x values that we're going to plug in to determine whether we're increasing or decreasing on these intervals. So then f prime, or dy dx evaluated at, let's go ahead and let this be f prime of x. This notation is easier to work with. Let this be f of x. Okay, f prime of negative 3 will be equal to 12 times negative 3 cubed minus 48 times negative 3. And if you pop this into your calculator, it's going to be negative 180, which means I'm negative here, which means I'm decreasing from negative infinity to negative 3. If we do f prime of negative 2, that will be 12 times negative 2 cubed minus 48 times negative 2. Now I'm getting that from over here, will be equal to positive 36. So between negative 2 and 0, I'm increasing, I'm positive. So I'm increasing on this interval. F prime of positive 1 would be my next test point. 12 times 1 cubed minus 48 times 1 is equal to a negative 36. Now I'm giving you the numbers. The numbers are kind of irrelevant. It's just the sign on the numbers that we're looking for. Are they positive? Are they negative? This one's negative. So I'm negative on this interval, which means we're decreasing because the slopes of our tangent lines are negative.
Is equal to 12 times 3 cubed minus 48 times 3, which is going to give us positive 180. So we're positive here from 2 to infinity, which means we're increasing. So we had to change from decreasing to increasing, from increasing to decreasing, and then from decreasing to increasing. So we're going to have two local mins and a local max. Let's write our intervals down. So we decided we were decreasing on the intervals from negative infinity to negative 2, from 0 to 2. We were increasing on the intervals from negative 2 to 0 and from 2 to infinity. We said we had two local mins and a local max. In order to figure out what the minimum maximum values are, we have to evaluate these critical values in the actual function itself. So then we're going to we'll go with our local max first. So f of 0 will be equal to, going back to the original, 3 times 0 to the 4th minus 24 times 0 squared plus 12 will equal 12. So local max is going to happen at 0, 12. Local mins. One of them is going to be at f of negative 2. So 3 times negative 2 to the 4th minus 24 times negative 2 squared plus 12 is going to equal negative 36 when you put it in the calculator. So we've got a local min at negative 2, negative 36. And f of positive 2 will be equal to 3 times 2 to the 4th minus 24 times 2 squared plus 12, which is also negative 36. We'll have another local min at 2, negative 36. Okay, so this is an important test. We use it quite a bit, and this is important information. And if you are running a business, you might want someone to maximize your profits, minimize your costs, things like that. So find where the graph of the function is increasing, decreasing, and has local extrema. Y is equal to x cubed plus 3x. Let's make this a g of x. Okay, so then first thing we need to do is get that first derivative. So g prime of x will be equal to 3x squared plus 3. All right, now we're going to set this equal to 0. 3 times x squared plus 1 is equal to 0. If we take this term out, set it equal to 0, it's not factorable. If we subtract 1, x squared is equal to negative 1. So there are no values of x that make that happen. So there are no critical values. So now the question becomes, from negative infinity to infinity, what is the behavior of this graph? So let's go ahead and test g prime of a number. Let's say 0. 0 is a great number to work with. So 3 times 0 squared plus 3 is equal to 3. So therefore, from negative infinity to infinity, because I've evaluated the derivative and it's positive, we are increasing. So never decreasing. No local max or min values. Okay. Let's do another example. Find where the graph of the function is increasing, decreasing, and has local extrema. Here's our new function. Let's go back to f of x. First derivative, f prime of x, 3x squared, minus 6x. Let's set that equal to 0. Okay, let's go ahead and take out the GCF. It's going to be 3x So leaves us with 3x times x minus 2. This is prime, so we're done factoring. Factors that contain a variable get set equal to 0, so x is equal to 0. And x minus 2 is equal to 0, therefore x is equal to 2. We have two critical values, 0 and 2. We're going to put them on the number line. We're going to box them in so we don't lose them, get them mixed up with our test values. We're going to get some test values, maybe -1, +1, +3. And then we're going to use those to determine whether we're increasing or decreasing. So we'll do f prime of -1, and that's going to be using this 3x squared minus 6x, or you could use factored form, either way. 3 times -1 squared minus 6 times -1, and that's going to be 3 plus 6 is 9, so that's positive. So we're increasing here on this interval from -infinity to 0. We're going to try f prime of 1. 3 times 1 squared minus 6 times 1 would be -3. So this is negative, which means between 0 and 2 we will be, let's put these in here, we will be decreasing. And f prime of 3 will be 3 times 3 squared minus 6 times 3, which will be 27 minus 18, which will be 9. So we're positive again over here, which means we're increasing again. Okay, we went from increasing to decreasing, so there's a local max there. We went from decreasing to increasing, so there's a local min here. So where are we increasing? Increasing from -infinity to 0, and then from 2 to infinity. We are decreasing from 0 to 2. We have one local max, one local min. So local max will happen at 0. So we have to do the actual function evaluated at 0. 0 cubed minus 3 times 0 squared will be 0. So 0, 0 is going to be the local max. And the local min is occurring when when x is 2, so f of 2 will be 3 times, not the derivative, don't use the derivative, that's just going to give you 0 again because that was critical value. Make sure you use the actual function, so x cubed. So 2 cubed minus 3 times 2 squared, which is equal to a -4, so we've got a local min at 2, -4. Okay, problems like this can be found on your textbook, in your textbook from page 201, numbers 1 through 86. Here's an application problem. Brody Electronics estimates it will sell N units of a new toy after spending A, thousands of dollars, remember this part, thousands of dollars, A is in, on advertising, where N of A is equal to -A squared plus 300A plus 6. On the interval, pay attention to this as well, from 0 to 300. So this is my interval, 0 to 300, inclusive. Find the extrema of the graph and graph the function. Okay, well, let's go ahead and do the first derivative. So n prime of A will be equal to -2A plus 300 plus 0. We'll set this equal to 0. Add 2A to both sides. 2A is equal to 300 divided by 2. A is equal to 150. Now, we're looking for local extrema. Local extrema cannot occur at an endpoint. If you were looking for absolute max, absolute min, and we'll do more on this, you would be testing both of those endpoints because the absolutes could happen there and also the critical values in between. So let's go ahead and figure out what's happening on either side of 150. So on our number line, we've got an interval from 0 to 150, and we'll box that in, and then 150 to 300. All right, so let's do a test value, maybe 100, maybe 200. Those are numbers on those intervals. So n prime of 100 would be negative 2 times 100 plus 300, which is positive 100, so we're positive here, so we are increasing. N prime of 200 would be negative 2 times 200 plus 300, so that's negative 100, so that's negative. So we're decreasing here, which means we went from increasing to decreasing, we've got a max value. So then local max at A is equal to 150. So $150,000 they'd be spending on advertising. And when we do N of A, it will be negative 150 squared plus 300 times 150 plus 6, which is equal to 22,506. We're going to be selling
22,506 units. Now, if we spend less on advertising, we won't have reached our maximum. If we spend more on advertising, we'll actually be selling less, so that would be wasted money.
All right, so then let's go ahead and graph. Okay, this is dollars. This is units. We're going to count by 50s. And by 5,000s. All right, if we do N of 0, it will be equal to 6, so we're really close to the x-axis here. At 150, we know we're at 22,506, so approximately there. And then if we do one more line here, 300, that will equal, let's see, we're going to have to do negative 300 squared plus 300 times 300 plus 6, so 900, negative 90,000, positive 90,000, those are going to cancel, plus 6, that's just going to be 6 again, so we're way down here again, and our graph does this. Okay, so if more than $150,000 spent, then your sales are going to start to decline. Problems like this can be found on page 202, numbers 86